Hi, everyone. Welcome to the BranchPattern webinar series. We are about to begin with our webinar, The Energy Health Nexus, presented by Pete Jefferson. I'm Danny Diono, and I'll be your webinar facilitator and moderator during today's presentation. I'd like to wish all of you a happy Earth Day. Thank you for spending your Earth Day morning with us. Before we start, I'd like to go over some housekeeping items and do a quick introduction to BranchPattern. Our name, BranchPattern, is inspired by the natural environment and how we use the natural environment to influence our design. Humans are innately fascinated with fractals, or repeating patterns, and we can use our fascination and observation of nature to improve our designs. In a study done by Richard Taylor, Human Physiological Responses to Fractals in Nature and Art, Stress Reduction, he found that people are hardwired to respond to a specific fractal pattern found in the acacia tree. The fractal patterns found in the acacia tree can help improve memory and problem solving. I'm inspired by the idea of mimicking the same fractals found in trees in our built environment and how purposefully placed patterns can actually help building occupants. By using nature to influence our design, we can create better spaces for people. Throughout our firm's history, our purpose has been improving life through better built environments. This is our mantra, and we use this message to influence everything we do as a firm, as engineers and scientists. BranchPattern is a building consultancy made up of many specialisms. Here you can see them listed. Pete focuses on whole building performance, leveraging our research and development in the discovery phase, the energy modeling team during design, and tests building systems with our commissioning services. Finally, he learns from past projects by administering post-occupancy evaluations and continuing to do research to learn and plan for the next project. While you will mostly hear about these specialisms today, it is important you know about the breadth of services we offer, which allows us to contribute to many aspects of building design. Our beliefs are rooted in nature, which has taught us that true sustainability sits at the intersection of human experience and environmental stewardship. Today, you'll hear from our presenter, Pete Jefferson. Before he begins, here are a few fun facts you won't find in his bio. Pete is a Navy kid. His mom was a senior chief with the U.S. Navy. Pete attended 9 different schools in 5 states and 2 countries. Attending all of those schools may be the reason Pete is so interested in education projects. He is a mechanical engineer by training, but often gets mistaken for an architect at ASHRAE technical meetings. We aren't quite sure why, but we'd love to hear your opinion in the post-webinar survey if you have some ideas. Pete hates yard work, but enjoys trail building. And this fall, he's celebrating his 20th anniversary. All right, Pete, take it away.
All right, thanks for the introduction, Danny. It's great to be with everybody. And just to kind of reiterate what Danny said, happy Earth Day to you all. It's a special day, the 50th anniversary of Earth Day. So really excited to be here sharing this time with you. A couple of things, of course, we've got learning objectives here, and the presentation does qualify for AIA learning units. But to orient yourself throughout the presentation, you can kind of think of this through 4 main sections. So the first section is really about understanding where we are when it comes to energy and health. The second section is understanding where we need to go with it. The third, how we might get there. And then the fourth is really the proof of concept and some case studies. So with that, we're going to get right in, and we'll kick it off with one of those fun little poll questions here. So the interactive piece here. So we'll give it a try. So the question for everybody here is, on your projects, which do you spend more time discussing, energy or health? And so while you're answering that, and go ahead and put your responses in, there's no right answer or wrong answer. We see the responses tend to come back a lot of times based on the type of role that people play on a project. So it's not uncommon for the engineers and energy managers, of course, to be focused on the energy side of things. A lot of times the architects and interior designers are the ones that are driving the health agenda. While there's no right answer or wrong answer, we are hoping to see better balance on most projects because these two things are connected. So let's see the results. So energy is about 55%, health is 21%, about equals 24%. So I'm actually encouraged to see that many people are responding with that balanced answer here. So we'll get into the presentation here and talk about how we might achieve better balance on more projects. So first off, we start with the understanding that energy and health are interconnected. We often think about building energy use and what that does to things like regional air quality. But that relationship is really complex. It's a little bit of a chicken and an egg scenario. We're constantly trying to figure out what comes first. Is it energy performance, or is it healthy outcomes both in our regional communities as well as our buildings? But we are at a really unique point in time here, and we kind of have to recognize this strange phenomenon that we are seeing happen right now play out throughout the world, where health is having a direct impact on energy use. So for the first time in a long time, we're seeing building energy use decreasing to a point that is new lows here. So I think this last week, we were at about 6% energy demand reduction compared to the same point in time last year. This is because our schools have closed, our offices have closed, our factories and industrial processes have shut down. So we've never seen this happen before in our life, where health directly is causing a decrease in energy use. And it's not just in the US, it's happening globally. This trend continues around the world. And as a result of this, we're seeing air is cleaner than it's been in our lives. Water, the canals in Venice, I read a story about how clean they are for the first time. But I think we all understand that this is temporary, and that hopefully in the very near future, we're going to return to some form of normalcy here. The big questions that I have are, what are we going to be talking about then? We are going to be presented with a completely different platform to talk about building health than we have ever been presented with before in our history. It's up to us as designers, building design professionals, operators, to think about the responsibility that we have and keep in mind that what we do in the built environment directly affects the people in our communities and around the world. So we're not the first to make this connection. I think my own personal story here, it became apparent to me back in about 2003, so almost 17 years ago. This cover here on Metropolis magazine painted a very literal picture connecting building energy performance and health outcomes. It was at this point in time that I was first introduced to the concept that buildings contribute about 40% of global CO2 emissions. And therefore, if we wanted to address that, we need to address building energy use. So we've seen that connection for a while. That was my first introduction to it. But there were pioneers working on this well before that point in time. I think that the same magazine, Metropolis magazine, had a really nice feature just last month that looked at the origins of sustainable design and really looked at the foundation of AIA's Committee on the Environment. So I'll call that COAT from now on for short. And that was established in 1990 by some really innovative, thoughtful people that, as you can see in the quote here, made a very distinct connection between our buildings and environmental health and the health of the communities around the world. So 30 years ago is when this was really formed and starting to move forward here. And they set out and they really understood that there was a timeline we needed to stick to, that if we were going to address this, we had to have some goals and some vision around the time frame that we had to get this done in. And so 40 years was established at that point. So here we are, the year 2020, with 2030 as the goals that were really targeted by that group of pioneers. Of course, we needed some tools to go along with that. So that led to the creation of the 2030 Challenge. And to date, there are about 800 firms that have signed up to take this challenge. The challenge itself ratchets down building energy use, greenhouse gas emissions, really sets targets for us to move towards a greenhouse gas-free, fossil fuel-free built environment in the future. These goals have ratcheted up about every 5 years or so. So as it stands today, our goals in 2020 are an 80% reduction from that original baseline that was established back in 2003 when the challenge was put in place, 2006. So as part of that, those firms that sign up also agree to report how their projects are doing. Many of you are probably going through this process right now or may have just recently completed it, but the annual accounting and reporting of building energy data based on energy modeled results. And so the firms commit to submitting that up to the AIA DDX exchange, and we get to see how they're doing. Now, what we would call this is really an energy first approach. So the vision was that energy was the problem, therefore the solution should also be energy. And we each have something to contribute to that through the projects that we work in and day out. So we wanted to approach this presentation really by understanding how are we doing as designers. So with that, I want to kind of kick this off with another little interactive feature here. So we've got another poll. That should come up momentarily. So we just want to know from folks on the call here today, is your firm a signatory to the 2030 challenge? First answer, yes, and you report annually. So what I was talking about, submitting the energy data on your projects up to the exchange, you do that every year. Yes, you've signed up for the commitment, but you either don't know if you report the data or you just haven't done it yet. No, you haven't signed up, or maybe it's not applicable. You might be from a company type that isn't really well suited for the 2030 challenge. So we'll give you a second here to see what the responses are. All right. Well, this is actually really encouraging. So about half the folks on the call are actually signatories to it and report annually. So kudos to you, and hope you are recovering from that big heavy lift of energy data reporting here recently. And I think we've got a good chunk of folks that aren't necessarily in the design community where the 2030 challenge is something that's a fit there. So you might be curious to know how we're doing as a design community, and that's what we wanted to explore in the next section here. So this chart here, there's a lot going on, so I'll kind of walk through it quickly. In order to understand the magnitude of the problem and what we needed to do, it was really helpful to have some projections about where we were going. So every few years, the Energy Information Administration did projections related to building sector CO2 emissions. And so that's what you see here is building energy use. And starting in 2005, they projected out where we would be at in the year 2030. That's what's represented on the top line here. You can see it doesn't look good at all. We're on a bad trend overall. And that's improved, though, with each round of the reporting that's been done. So that middle line there, the yellow line, that was updated in 2009, and the trajectory changed. We were actually looking like we were going to use significantly less energy in the year 2030 than what had been predicted just a few years earlier. And as it stands right now, we are actually projecting to use less energy in the building sector in 2030 than where we started in the year 2005. So that can be really encouraging. I think it's impressive and significant to understand that buildings are equivalent to a reduction in about 1,200 coal-fired power plants per year. But in order for us to understand where that comes from, it's helpful to think about the things that contribute to that energy reduction overall. So we understand that codes have an impact on it. When codes are updated, they almost always include revisions to energy targets and include factors in it that improve energy performance on buildings. The other thing about the last 10 years is we have seen a transformational shift from coal-fired power plants to natural gas plants. Now, those do come with their own issues, but from a CO2 standpoint, are responsible for less than the traditional coal-fired power plant. We've also seen a big uptake in renewable energy production, both at the utility scale as well as buildings. Now, those first three things I mentioned are very scalable solutions, so they impact a lot of buildings in the region there. Unfortunately, what we can't really extract from this data is how much can we really take credit for through good design, through things like the 2030 challenge. That's what I wanted to understand a little bit more before we get into the connections between energy and health. So looking around, this publication was put out by AIA a few years ago. It's actually a really great read overall for any design firm to take a look at. And what the AIA did was reach out to 10 of the top performing firms in terms of design firms that had won more AIA COTE Top 10 awards than any other firm out there. So the COTE Top 10 is basically the most prestigious design award every year if you're interested in sustainable design excellence. So obviously, a lot of submissions, and a very limited pool of projects that are selected from it. So AIA studied the firms that are winning the most. We wanted to do the same here and maybe see if we can extract some information about how much good design is responsible for those energy trends. So first off, as you might expect, 100% of the high performance firms, as they were called, were signatories to the 2030 challenge. And that is obviously significantly more than the industry average. The industry average was less than 2%. I'm encouraged by the poll response here a few minutes ago because we've got a much higher rate of participation, I think, than what happens in the industry. So thank you all for joining and listening to this. The second line, what this looks at though, is the firms that are submitting. So those high performance firms submit, about 70% of them submit annually to the AIA DDX exchange. One thing that is maybe a little concerning here is that less than half of the signatories have been doing that overall at the time of this report here. And jumping down to the last line, I think this is one of the big takeaways for me. Projects meeting 2030 targets. So it's less than 4% for both the high performance firms as well as the industry average. So what that says is the 2030 challenge really is a challenge. It's tough to hit those goals. And I think we'll understand that a little bit better in the next few slides. So one other thing that jumped out to me from this report is the use of post-occupancy evaluations. So we call these POEs for short. There are a lot of different definitions for what a POE is, but most commonly the way they're applied is to go back into the building after it's being operated and better understand how it is being used by the occupants, how it's working for them, as well as actually starting to get some of that real actual energy use. And what we see is the high performance firms do POEs many orders of magnitude greater than the industry average. So as cited in the report and as we've seen through our own work, these are firms that are interested in understanding how their buildings actually work. And they take those lessons learned and they roll them into their next project to get better. So I think that's encouraging. The second study that we can look at, if that first one was really focused on the firm, the second one, also by AIA, looked at the COTE top 10 award-winning projects themselves. And so we want to understand how do the energy performance of these projects play out as well. So if these are the best examples of sustainable design excellence, how are they doing? So one of the graphs from that study shows how the winning projects perform compared to the 2030 benchmark at the time. So going back to that original 2003 benchmark that we use throughout. So you can see as each year goes by, the trend is upwards in terms of energy reduction from the baseline. So that's a good trend. But where do we really sit at? I think it's important to note that while the trend is upward, the trend is basically keeping on par with 2030 targets year over year. So again, 2030 is a challenge. The 2030 challenge is not easy to get. If these are best examples of sustainable design excellence, and they're often either barely meeting it or just coming up short of it, tells us that this is really not an easy thing to do, that we shouldn't just accept that 2030 performance is a normal thing. We really need to acknowledge that it's exceptional and extraordinary that when we hit those goals. So it should give us some sense of understanding at how difficult that is and what that means in terms of design performance. So a couple more things. That last chart was a few years old, so we wanted to backfill some of the missing information from it. So we took a look at this last year's set of energy results. So last year, the goal was a 70% reduction, and what we see across the 10 winning projects was that they averaged 71%, so they just barely hit the target there. One other thing to note, that's based on predicted energy use. Starting in 2016, COTE started to encourage the submission of actual energy use as well. So 5 of the 10 projects submitted actual energy use to go along with it. That meant that 5 didn't have that at that point. Now, from a global CO2 standpoint, we care about actual energy use. So it's going to be really important that we are monitoring that in our buildings. And the last part is that 6 out of the 10 had actually completed a POE at the time of the award. A couple of them said they were in the process of doing that. So that's encouraging. I think that's important to fill out the big picture though, so that we understand both the actual energy and the actual occupant experience impact of it. Okay, so we have a lot of people on the call. I know from the middle part of this map here. This has been a trend for 20 years that a lot of the projects come from our coasts here, particularly the West Coast. And so one of the few things that the report noted was energy codes are generally more aggressive there. Climates are milder, but there is also a climate of sustainability performance here. So going back to that original purpose, that original mission of reducing global CO2 emissions, if we want to do that as an industry, we have to start seeing more of these projects popping up in the middle parts of the country and just with better balance overall. So in conclusion, I think the takeaway that I had going through this exercise is really a great understanding that projects that hit 2030 targets are exceptional. They represent, on this diffusion of innovation curve, that 2.5% there that are the innovators. That's not enough if we want to solve global CO2 emissions, and by way of doing that, solve health problems. We need to find a way to move more projects from the middle up towards that greater level of performance here. I think if we are going to do that, we have to find different mechanisms to do that, different incentives to do it with our owners and the people that we work with day in and day out. So if we're looking around, that brings us to health as a potential lever for energy efficiency. I think what we have seen a lot of in the past is energy is presented first and health is a secondary outcome to it. What we are proposing here is that we think about a greater balance, or potentially even shifting that to being health first in more conversations. So the first part of being able to do that is actually understanding whether or not we have a role to play, and a significant role to play, in health outcomes for building occupants. So our friends at IWBI, they created the Well Building Standard. You'll see a few of their metrics that they've provided here, and I'm thankful for them. This is pretty shocking to me. Now, we don't proclaim to be health experts. There are multiple different fields and aspects of health, but from the studies that have been presented out there, it is really staggering to me what the physical and social environment can do for health outcomes of occupants. That's both in the building and outside the building. So if you think outside the building for a moment, one of the things, unfortunately, that we see very often is much higher rates of asthma in urban communities that are generally in more impoverished areas. Why that happens, those communities tend to be closer to industrial processes and things like coal-fired power plants. So again, that ties back to our building energy use, and the location of that physical environment for those people has a direct impact on their health outcome. Now we can extract that and also understand that a lot of people go to work in buildings that aren't necessarily conducive for great health too. So if we rethink our approach there, we have the opportunity in many of our projects to provide a safer environment, a healthier environment for the occupants than they might experience any other time of their day. So for us, as engineers and building scientists, we think about physical health in the built environment really through the lens of indoor environmental quality. There are also a lot of definitions for what IEQ is, depending on your source. In the United States here, we typically talk about indoor air quality, IAQ for short. We talk about smells and odors. We will talk about thermal comfort, visual quality, and acoustics or sound. I think it's really interesting, though, that when we look at places like Europe, which tends to be a little more progressive than we are, they're actually starting to incorporate other aspects and other definitions of IEQ as well. Electrostatic and electromagnetic, for example, is really trying to understand the impact that things like radio frequency, Wi-Fi has on our daily lives. There's a lot of unknowns associated with that, and it creates its own category in Europe. So we're a little bit behind there in understanding some of that. But they also embrace biophilia in some of their examples of indoor environmental quality. And I'm encouraged to know that that's a much more common conversation here in the US these days. And the last one, proxemics, privacy, and personal control, we often talk about that in terms of agency. How much control do people have over their physical space? And we see direct outcomes on their perception of building health when they're given greater sense of agency in their space as well. So that was the first part. We've established that we have a role in the health of the occupants in our building. In order for us to use it as a lever, though, there also has to be a financial incentive for us to do so as well. So brings us to our next poll here. So we're going to ask the question, who drove the energy efficiency agenda on your best performing project? So think about that project that you're especially proud of. Maybe it's your most recent one. Maybe you have to go back in the past a little bit, but really who set the tone on that project that led to it performing outstanding in your mind? All right, and we will give this a couple more seconds here. All right, and while I wait for the results to come in here, let's see, they're coming up. The owner leads the way at 39%. Second is all of the above, it was collaborative. So your results are very much in line with our expectations and our experience as well too. When I think about the best projects that I've been able to work on, what's typically happened is we've responded to an RFP that the owner has put out with some really strong sustainability and energy performance goals in it. That led to the creation of a really great team that responded to it. And then that was consistent throughout the project. It led to the creation of designs that met the owner's expectations on it. You know, I think our struggle becomes when we are trying to do this from the bottom up, either as consultants, as architects, and we're trying to get people engaged in this discussion that haven't brought it up themselves. So part of the reason for that, apologies here, I think in my own personal experience, I had some frustration and came across this rule here about 10 years ago. And from IWBI has done a really good job of making this more popular. So it helps to understand why at times it is so tough to engage the owner in these conversations. And I think what this 110-100 rule has done is really make that evident to us. So essentially the 110-100 rule in a nutshell is that for an organization, for every $1 that they spend on energy, they spend about $10 on rent and operations and about $100 on their staff. So if you're in New York City or if you're in San Francisco, multiply it by about 4 or 5, and you've got the 440-400 rule. So again, you know, that frustration and understanding that by not having those results or those goals stated up front by the owner, we were much less likely to achieve them. It helped to understand why it's so tough to engage the owner and decision makers in some of these conversations. They are largely viewed on the performance of their people. It's how they're judged. It's what their key performance indicators, their KPIs are, and it's how the performance of the organization is really judged. So unless their organization has sustainability woven throughout it, it's tough to sometimes get them engaged in that conversation. So from their standpoint, energy's cheap, people are expensive. So that really brings us back to this notion of financially, we need to find a way to engage people and leverage them to also achieve energy performance. So again, we do that through the lens of indoor environmental quality. But instead of just thinking about IEQ as indirect outcomes of our design, we can start to think about them as directly related to the financial performance of an organization. We see IEQ affect a lot of different things in terms of people and how they perform. If we can actually figure out how to determine the cost benefit of those, that is really powerful. So let's look at it through the lens of how an organization might see their costs and their benefits, their KPIs for short here. So a lot of these things are directly impacted by IEQ. The challenge, of course, is measuring those things. How do we can't really set a meter on things like productivity and health at times, but there are studies that we can leverage, and if we can do so, it gives us the opportunity to make the financial case for it. Okay, so we understand that we have a role in building occupant health. We understand that there's a financial case for it. The last part is really understanding whether or not there's a connection between IEQ and energy. So let's take a look at that. So in the course of a design project, we will often be involved in the development of energy conservation strategies. And almost always, these are put forward as ways to save energy for the project. And the discussion that follows, if there is any discussion about occupant health, it's secondary. The other thing is those results are also typically presented qualitatively. So we might say doing X contributes to good Y. We don't really put the same sort of metrics on it that we do on the energy side of things. And that's understandable. It's hard, but we do see a lot of these features, a lot of these strategies can be presented from an IEQ standpoint up front. So in order to determine the connection that a lot of these have here, let's just take one example that exists. And it's my favorite one because I think we have some of the best research around it and best tools to address it, and that's thermal comfort. So it helps with understanding really what is normal in the built environment. And the first thing is that most designers really don't understand how thermal comfort is created, and especially how complex that is. We typically just think about thermal comfort as one thing only, and that's air temperature. Unfortunately, it's way more complex than that. There are at least 6 different physical traits of the environment that affects thermal comfort, and many, many more if we take into account psychological. So the result is that we think about one thing, we prescribe that responsibility to usually the mechanical engineer and say, you take care of thermal comfort. And the reality is we create these complex environments, as shown in the illustration on the left here. Things don't always play out the way we want them to. So how often have we seen people whose workstation is pushed right up against the glass? They're hit with direct sunlight, causing radiant heat issues, glare issues. We respond to that. We dump a bunch of cold refrigerated air on their head. And when they complain, we might go out there with a data logger and find out, oh, it's 72 degrees. You should be fine. It's not reality. And if we think this is rare, or that we know better, or because we're doing a LEED building, this doesn't happen, unfortunately, that's not the case. So what the data points us to, especially in some of these larger case studies and sample sizes, is thermal discomfort is actually the norm in our buildings. So ASHRAE and LEED both point us towards 20% rate of thermal dissatisfaction. Another way of saying that is if 2 out of 10 people in the building are uncomfortable, then we've hit our mark. So one could argue that's not already a really high bar to achieve, and we fail to do so there. So that was one study. We've done some of our own. So for the last decade, we've been engaged in doing post-occupancy evaluations for the state of New Mexico on their new schools and newly renovated schools. A lot of these are LEED schools, and we see similar trends play out. In fact, it's worse for the students, and part of that goes back to the agency thing. If you think about who controls the temperatures in a classroom, it's most often the teachers. And so we see that play out. As part of those POEs, though, we can actually go in and have gone in to extract energy data from those projects as well. And we see a really clear link between the energy performance and the thermal comfort satisfaction in these buildings. Basically, it's almost a stark contrast. We either see buildings that are efficient and comfortable, or inefficient and uncomfortable. So I'll pose the question, and maybe we'll use the little hand raise here. Are these buildings less comfortable because they use more energy? So if you agree with that statement, raise your hand. Or are these buildings less efficient because they are less comfortable? So if you agree with that, raise your hand. I'm seeing that start to increase there. I think our facilities managers and operators would tend to agree with the second statement there. If you think about it, how often does a hot call or a cold call lead to adjustment of the controls and the things that take the building actual performance away from the expected performance. It happens all the time. And this is just one segment of IEQ that we're looking at here. This particular study here, you could say it's a small sample size, not that many buildings, not that many occupants, but we see it play out across the board. Okay, so one thing that a lot of people don't know is that we can actually model a lot of these things. It's not often that it's done, but that doesn't mean that it shouldn't be done. So I'll walk through a few tools that we've used and like, and the first couple tools here are free. Center for the Built Environment at Cal Berkeley is constantly developing new things that are really beneficial for us as practitioners here. So the one on the left that a lot of people use, perhaps in lead projects, the thermal comfort tool, allows us to look at different spatial conditions and understand what percentage of people might be dissatisfied in the space. But I also like this set point savings calculator on the right here. That one's pretty cool because what it allows us to do is change temperature set points, perhaps because we are incorporating ceiling fans or we are using mixed mode ventilation and operable windows, or we are encouraging our occupants to dress appropriately for the weather. It's actually a really nifty little tool to understand the impact that that has on energy, just kind of at a basic level. It's not an exact tool by any means, but going into a project in the concept phase, it's really neat. The next tool is actually free and on their website. So PAYETTE is an architecture firm in the Boston area. And they came out with this tool a couple years ago that I've used a ton. It is a glazing and winter comfort tool. So that example that I showed about that poor person that was programmed right up against the glass there, I've actually had that happen on projects where I look at a floor plan, I see a bunch of workstations right up against glass, and that glass is floor to ceiling. Intuitively, I expect that to be a problem. And with about 10 minutes of using their really nice tool here, I've been able to prove that out. So as a quick little example of that, if you're like me, you've tried to pitch, say, triple paned glass on projects before from an energy standpoint and likely failed at that. In this particular case, we presented info from this tool that showed about 50% of the occupants within 10 feet of that glass would be uncomfortable in the wintertime. That is what resulted in the use of triple paned glass. That also came with energy benefits. So there's a great example with about 10, 15 minutes worth of evaluation, how we could prioritize IEQ metrics and use that to also get good energy performance. So a few more of the tools out there. Some of these are embedded in the tools that we use every day. So we like to use IESVE as a software platform for our energy and daylight modeling. We can also use that to generate thermal comfort predictions as well. So some of the tools that are out there give us ways to model it, model the IEQ performance. These are more complex. They come with more cost typically, but they do exist. And so particularly if you have areas of the building that you're sensitive to, some of these tools can help solve those problems. So the last one, and if you've been a participant on our previous webinars, you've heard some references to this before, but this is our happe tool that BranchPattern developed. So happe stands for Health and Productivity Performance Estimator. It's been about 10 years in the works here. So we are fortunate to have an R&D team that is constantly pulling in secondary research, reviewing it, determining what's good, what's not good, and what we should incorporate into the tool. But we've used this tool to look at things like expected student test performance based on ventilation rates. We've looked at it to try and estimate productivity improvements because of things like ventilation effectiveness or agency or improved controls. So what we are trying to do is take those financial incentives that I mentioned a few slides back there that really matter to an organization and start to put some dollars to those. So I'll show some of those examples in the case studies here, but I did want to make everybody aware that given the current interest in designing for reduced viral transmission, we've actually built out a module for this. It's something that we're going to put on our website, hopefully in the next month or so. It'll be free for anybody to use. And really what it's going to do is take what we find is the best, most rigorous research out there and turn it into a calculator. We're going to dress this up a bit. This is kind of the raw beta version of it, so hopefully make it a little more user-friendly. But I'd encourage you, if you have an opportunity to use that in the coming months here to help make some design decisions, give us some feedback on it. We want this to be a tool that helps the industry, so we'll welcome any feedback that you have on that. Okay, so putting it all together, this is the proof of concept stage. So we see a role that we play in health. We know there's a financial incentive. We've seen a cause and effect relationship between IEQ and energy, and we know we can model it. So I'm going to walk through a few examples of how we've done that. So the first project is with a really well-known client, Google. They were working on a project that wanted to incorporate a lot of biophilic design principles. And the first thing I should say too, kind of going into this case study and the next, both of these are workplace examples. Workplace examples can be really challenging project types to try and push an energy efficiency agenda on. Most often we are working in an existing box that already has systems defined, glazing defined for us. So our palette is limited that we can draw from here. But we recognize that this particular client had an interest in biophilic design. One of the strategies that represented biophilic design was ceiling fans. Most people don't think about that. Most people think about biophilic design as green walls and plant life and maybe some patterns and materiality choices. But actually air movement is recognized as a biophilic design concept. And part of that is it's also associated with improved cognitive function. It gives the users a way to have some agency over their space, their thermal comfort, the breezes that it creates. From a physical standpoint and a mechanical standpoint, it actually allows us to dump less refrigerated air on people's heads when they're operating the space. So rather than just sporadically sprinkling ceiling fans throughout a space, there needs to be some intentionality to it. So that little hand sketch there came from early in the design, thinking through how people use the space, how they move in it, and what sort of sensory experiences they might get. So again, we led with IEQ factors here with the expectations that a strategy like this can also save energy. So how did it work? We were able to actually get in with our partners on this project, Perkins Eastman Architects, and do a POE on it. And what we saw was really high reports of thermal comfort throughout most of the space here. People have agency, so they can choose to keep their temperature set points at a more traditional set point of, say, 70 or 72 degrees Fahrenheit. But in actuality, people are choosing to keep their spaces much warmer in the summer months. That's energy savings right there. But they're doing it because that's what creates comfort for them, not because it necessarily creates energy. And the last thing, in one of my favorite quotes here, the ceiling fans are awesome, especially since we figured out how to reverse the airflow. So that means in the winter, they wanted to reverse the airflow so they're not getting a direct breeze on them, but they still loved the indirect breeze that was created by the fan, so they reversed them at that point. Okay, the second project is also a workplace project here. This one's a confidential client that I can't disclose. This is not actually their building, but this is representative of their building. They came into the project interested in having one of the healthiest workplaces in the region. And they also brought in a little bit of an idea, preconditioning or a preconceived idea of doing underfloor air distribution. Really goes back to their previous space, and some of their global workplaces have had thermal comfort problems. So what I talked about in terms of thermal discomfort being the norm, that was their norm here. And so they understood that there might be a way to improve that through the use of an underfloor air distribution, or UFAD system for short here. Unfortunately, early in the project design, it was determined that it was going to be really costly to implement such a system, a $2.6 million ad, which for that size project is really significant. So I know how this would usually go, and I'll play that story out here. UFAD systems are known to have pretty significant energy savings potential. And so from a modeling standpoint, that would typically be modeled. The annual energy savings would be calculated, and then anybody looking at that's going to do a really quick payback analysis in their head. In this particular case, that's a 21-year payback. That's a tough sell. it's made even tougher when you understand the challenges of a multi-tenant building and a workplace project here. Any energy savings generated from that are typically shared with the other tenants. It's really tough to go in and meter individual building energy use when so many systems are shared. So if you're going to a client, you've got a 21-year payback and you're making an energy case, 99 times out of 100, I think that exercise fails there. So we didn't want to leave it there though, and that's where we were able to leverage our happe tool and our R&D team and present a different case for it. So with that estimator, we were able to, using their average salary metrics, put in some rough order of magnitude costs here to estimate what benefits would come from improved local temperature controls and IAQ perception. If you compare those costs to the energy costs, many, many times higher. Again, think back to the 110-100 rule. Not surprising to see this sort of thing. That was a really powerful set of metrics to present to the client, who ultimately did choose to incorporate the system in. The other thing I would say, it was our first time on that last line here, the reduced virus transmission. This conversation happened almost 2 years ago. And I recall using this information and the impact that it had. It was our first time leveraging some of the research that exists around reducing viral transmission, really kind of pressing on their end to go ahead and improve this. And so, I think this is where we want to take some of that metric in the future with introducing the viral transmission tool to that. Okay, our second case study, or third, excuse me, moves towards a ground up construction here. So we do a lot of education work, especially in K-12, and we're fortunate to work with a school district that is very progressive and has some really ambitious goals of carbon neutrality across the entire district. So they were setting out on a series of new schools that they called exemplar schools, and they wanted to achieve a net zero energy ready building. So a building that was low enough in energy that when they came in and put solar on schools across the district could achieve the energy goals. Now, we've benchmarked a lot of net zero energy schools around the country, both those that we've worked on and those that others have done. And by and large, they almost all rely on the use of geothermal systems to help get there. Unfortunately, just given the local bidding climate there, the lack of available installers for it, the costs were pretty much determined to be unreasonable for the project. And so we kind of went into this, again, with a limited palette. But we didn't want to leave those energy goals behind. So we had to find different mechanisms, different ways to incentivize good energy performance. So with that, we led with indoor air quality. We leveraged some of the research that's come out from Harvard and the COG-FX study, as well as some of the research that had existed prior to that. We really wanted to embrace the climate and understand that fresh air and breezes that could be created in a relatively mild climate during a lot of the school year could benefit student performance, both from a cognitive standpoint, as well as just a physical feeling of well-being in the space. So the entire design became based on that concept there. We leveraged radiant heating and cooling, understanding that that creates better thermal comfort conditions for people, but also that is one of the primary ways that we can save energy, by moving water around the building instead of blowing air through fans. So from an outcome standpoint, we've been really pleased with the results on this. We are trying to get a formal POE done that's been a little bit delayed with the current conditions out there. But we've talked with the operators, we've talked with the people that run the building, who have a direct line to the teachers and people in the building. And they've said, by and large, this is the highest performing thermal comfort school that they've got and have had. Through that first year, they had 0 comfort complaints, which is almost unheard of in a new building. And on top of that, even though we increased ventilation and did some things that maybe come with a little bit of an energy penalty, it still performs on par with one of their projects that was designed really with energy first in mind and potentially some compromised environmental conditions in that. So we're proud of that outcome. Again, taking IAQ and putting that at the forefront to get good energy results as well. Okay, our last case study is one that's near and dear to me. We've been working on this one for quite a while. It's not often that you get to work on a 130-year-old building that was commissioned by Andrew Carnegie himself. So this was a real joy to work on. We had an amazing owner who I hope is on the call here. Chris, if you are, it was fantastic working with you. And the project set out after some initial sustainability charrettes here with some really ambitious goals of providing a really healthy, comfortable space that followed well building principles, but that also met the Pittsburgh 2030 targets. So Pittsburgh 2030 targets, Pittsburgh's part of the largest 2030 district in the country. And so the goals align with Architecture 2030. So getting into a really old building with really thick mass walls, I think a lot of you have probably had that challenge before of what to do about insulating those. So we know insulation has an energy benefit in most buildings like this, but it's also challenging. And so we spent a lot of time looking at different potential solutions and really found one that we were excited about. It's called thermal plaster. And the reason for the excitement on that was not just that it would help on the energy standpoint, but it would improve thermal comfort, and it would also improve the acoustics. It's got a lot of really good acoustical properties. And because it's a plaster applied product, it allows us to keep a lot of the historical character of the building in place, as opposed to the typical studs, furring, spray foam, and covering all that up with drywall there. That particular solution also was responsible for about 11% of the total building energy savings. So that was significant as well. So along the way, and I'll kind of mention this here, one of the questions that often comes up is, can IEQ lead to increased energy use? Do we ever make decisions that add to energy? And the answer to that's yes. This is a great example of one of those. So we were advocating for increased ventilation, again, largely based on the research that shows that we tend to underventilate our buildings here. So on this diagram, what it shows us is through the number of strategies that we incorporated, one of them was to increase the ventilation, and that came with a slight energy penalty. You see that kind of line coming back into the chart there, labeled indoor environmental quality. Now, that did add energy there, but I think it's important to also give that some context. Part of the reason why it's so little energy that is put back into the project is because we used something called an energy recovery ventilator. That's not necessarily required by code. It's an energy efficiency measure. Now, when we start to advocate for increased ventilation, then an energy recovery ventilator almost becomes a necessity for it. So yes, it adds energy, but it also allows us to normalize an energy conservation feature that often is left to value engineering. So had this not incorporated energy recovery, that cost would have been much higher there, but it also made it kind of an expectation it would be included. So outcomes, we are a little over a year outside of the initial occupancy of it. And again, we've had an owner that's been super engaged in this and working with occupants and providing information. And that first year of energy data came back, and we actually outperformed the model targets for it. So this is the first existing building in the Pittsburgh 2030 district to achieve the current level of Architecture 2030 targets. It came into operation in 2019, so those goals were 70%, and it's actually performing at about a 76% reduction from the baseline. We've seen through commissioning a high level of indoor air quality, and that's been reported from the occupants. And lastly, and I think this is maybe the most important thing of all, is it serves the mission really well. This became a finalist, and we're waiting to see what happens here with the results, but for South by Southwest's National Learn by Design competition. So I think it was one of 4 or 5 projects selected across the nation based on educational and rethinking learning. So that's maybe one of the most inspiring things to me, is how you can get good IEQ, good health, good energy performance, and serve a mission really well. So with that, we'll kind of move into Q&A here in a moment, but I just want to say, here we are, Earth Day 2020. We've got 10 years to go before we hit the end of that 2030 timeline. So these next 10 years are going to be really critical. I also think we're going to be faced with an unprecedented platform to talk about building health here in the very near future. We can do so in a way that increases energy use, or we can do so in a way that decreases energy use. And when we think about how that energy is generated, what that does to our global and regional communities, and especially vulnerable populations, I think we have a responsibility to think through these conversations in such a way that we get both. We get great quality and health for our occupants of buildings, but we also take that responsibility to heart. So with that, I think we have one more poll, Danny, right? And then
Yep.
on to some Q&A.
Yeah, so I do want to invite you all to let us know if you'd like to participate in a follow-up discussion. One of the folks from our sales team will reach out to set up a meeting with you if you answer yes. So I'll just kind of leave that up here as we go through the rest of our Q&A portion. But before we start, Pete, if you could advance the slide there. I do want to let you all know we scheduled our next webinar, which will actually be at 11 a.m. Central Time, considering health and wellness for distribution centers. So that is up on our website, and I'll be sure to send you all a link with this survey here. Okay, so let's jump into Q&A. I did have a question come up during the presentation that I answered, but I just want to make sure I answered it correctly. So could you remind us what the 10 is and the 1-10-100 rule?
Sure. 10 is rent and operations. So what you physically pay for rent, as well as there are typically some ongoing operational costs in the building, maintenance. Sometimes you'll take on some of the lease costs as well if you're a tenant in a building that the owner pays for, the landlord, I should say.
Great, thank you. Let's see, who manufactures thermoplaster? Do they have the product specifications available?
Yeah, so we would love to help with that. It was actually an Italian product. I think it was the first US application, at least in a commercial building of it. It's a group called Diathanite. I will mess up the spelling, but it starts with the D-I-A-T-H. And then you might be able to fill in the rest. What's really awesome is it's also, if you care about, I didn't mention the air quality aspects of it, but it's basically cork, diatomaceous earth. It's just really kind of all natural stuff. I'd actually love it if that company would go through Red List certification process there, because I think they do well with that. I think distribution's a little limited in the US, but if you want, we can follow up. Our building enclosure specialist worked on that and can share some of that info. And
it does look like Chris from the MuseumLab is putting into the chat here the product name. So thank you, Chris.
Here's our active and engaged owner.
Yes.
Awesome.
Okay, what type of renewable energy did the Children's Museum utilize?
Yeah, so within the 2030 challenge, it gives you an ability to utilize renewable energy or renewable energy credits. So the Children's Museum campus purchases 100% of their energy from renewable energy sources. Now, for 2030, you can only take a small percentage of that into credit. Because it's a historic building, it's got a slate roof, on-site renewable is not really a possibility. But again, we took the credit that is laid out in the framework for 2030.
Chris also mentioned that they buy offsets as well.
Yep.
Not enough sun in Pittsburgh.
Well, we would have loved to put solar on it, but yeah, that's a tough roof to do there.
When you increase outdoor air, do you mean by volume or by air change rates for a space? When you talk about increasing outdoor air to improve indoor air quality, which one is more effective?
Yeah, so it helps to understand kind of what typically is allowed. On a lot of high performance buildings, what's utilized is demand control ventilation. So that's controlling outside air flow rates in response to CO2 typically. What code allows us to do is actually a lot higher than what we see as good responsible choices to do based on the standards that exist. So code would actually allow for, say, almost I think 1,100 parts per million of CO2 in a space. And the research shows that the closer we can get to ambient, which ambient is around 400, the better for the health of the occupants. So typically when we're advocating for increased ventilation, it's really about reducing the CO2 set points in the space. Now to hit those CO2 set points, we need more volume of air. Just providing the typical ASHRAE quantity is usually not enough. So if you're thinking about this from a LEED standpoint, that credit that is there for 30% more outside air than ASHRAE 62. That's usually enough to help us hit those lower set points that we're trying to get to. So those lower set points are usually what we are promoting is around 600 parts per million instead of the standard of 1100 parts per million. So, thanks.
Great. Okay, we have a few more coming in. This is awesome. Do you have any recommendations for advocating occupants to adjust their attire for thermal comfort?
Yeah, so that's, we do see there's a relationship. That's one of the 6 physical factors, right, that affect thermal comfort there is clothing, metabolic rate, what they're doing in the space. I think it's a dangerous game when we start to promote people changing their behaviors to meet our goals of the project. So most of the time we're not advocating for them to dress differently, not in the role that we play in an organization. What we're trying to do is better understand how they actually do dress and work and move around their spaces, and then try to provide a space that responds accordingly to that.
Great, thanks. Do you know of any healthcare systems or owners that are clients of yours that have adopted the 2030 challenge? Or maybe are there any healthcare facilities that have won a COAT award?
Oh, that's a great question. Our healthcare sector leader, Rick Manaktawa, I think might be participating here. So this might be a good opportunity for us to use the chat function on it. I personally am not aware of any 2030 COAT award-winning hospitals. There are quite a few, I would say, science and research facilities, though. I'm actually going through some precedent research now, looking at COAT top 10 award-winning projects in the science and research sector. They definitely use more energy use than a standard building, say a general educational building, but we are seeing some really outstanding design work happening in that sector space. And I think it's really important because if you think about the energy standpoint, those are buildings that would typically use 3 times more energy than an office building. So if they're saving half that energy use through really good sustainable design, that's a huge impact that it's having there. So yeah, we're seeing a lot of that, and hopefully Rick can contribute from a healthcare standpoint if he's seeing any. I know he's had some contact with some leaders in that sector around the nation recently.
Great, thanks. Does increased outdoor air also have an effect of flushing out viruses, even if not measurable with monitors?
Yeah, that is an area that we are learning a lot of every day. If you're watching a recording of this, things may have changed if you're watching this 2 weeks or 3 weeks from now. We do see a relationship between air changes, certainly not just on the current virus that we're dealing with, but viruses in general. That is one of the factors that there seems to be really good, strong supporting evidence that increasing the air change rate does reduce the rate of the virus that exists there. And that's one of several that exist. There's a lot of noise out there right now. I think we're all still trying to get a handle on where do we go from here in our buildings, but that is one of the techniques that's going to be there. But we certainly understand that has an energy impact too. So I think we're going to have to look at how do we take what we are learning from COVID-19 and apply that to buildings moving forward. I also think we're going to have to start to really think about the classification of our buildings. Maybe those high air change rates are appropriate, but for certain building types that need to run throughout a pandemic, as opposed to most building types where we're trying to create just healthier spaces than what may have been the norm. So we're going to have to look at those carefully.
Thank you. Okay, here's some from the chat. While we as owners and operators have the greatest intentions in mind for being very proactive and conscious, but are in some occasions overridden by cost and community groups, is this experienced in many areas across the country?
Ooh, I mean, certainly budget is, I think, a challenge on every project. And I think what it comes down to is everybody wants to maximize their budget. And in doing so, we are constantly making trade-offs. So to promote health, and by way of health, promote energy, I think a lot of what we're trying to do is just quantify and make it more tangible and quantitative, the value of that. So that way those decisions have a better chance at being included in the project. Every project's gonna have budget cuts on it. I think what we're trying to do is demonstrate the significance of the things that we know have health outcomes on them and protect them from value engineering. So I don't know if I answered the community question very well there. I'm not sure I quite grasped that one, but certainly from a budgetary standpoint, that's one of the tricks that we're doing there, and hopefully what you're seeing here. So if you can maybe clarify that in the chat a little bit more, I'll take another swing at the community side of it here.
Okay. We have a question about the accuracy of IEQ monitoring devices and what our experience has been.
Yeah, so the accuracy of IEQ monitoring devices. So there's some different devices out there. They range from consumer grade to lab grade. So if you are going for well building certification, for example, an assessor comes into your building with lab grade equipment and sets that up and then measures, and some of that those samples get sent off to a lab, and that costs thousands of dollars. And then there are also consumer grade models that might cost $100 that give you the same sort of information, but the issue is the quality of it. Is it any good? In between those two things, there is higher quality, more of professional grade but not lab grade equipment. That tends to be pretty close, and so it's a trade-off of quality versus cost. I would say we are seeing more application of those professional grade devices throughout spaces. It is important to look at what's required for recalibration on those, because if data, it's no better than no data at all. And they all vary quite a bit, but typically, I think what I see is about 5 years is kind of the best case example of when those things need to be recalibrated. So you have to factor that in along with the cost too. But it also helps if somebody's monitoring that data. If things don't tend to just kind of catastrophically fail, and if they do, you should see that if you're paying attention. So we are monitoring building performance now, definitely.
We did get a message from one of our attendees. I don't want to call you out since you did send it privately to us, but it looks like HOK's, they have a hospital in Singapore that is a COTE top 10 winner, and then the San Antonio Military Medical Center by RTKL. So
okay, great.
Good examples. Yeah, thank you for contributing.
That's the awesome thing about having such distinguished attendees here. Is
yes.
They know a lot that we don't too, and can fill in some of the blanks. So thank you for that. I'm not sure if that was Mara or Vanessa or Allison maybe, but yeah, that was awesome.
Okay, we have a few more minutes. We do have one more question here. Are you seeing more UV light applications? What other ways can a virus be deactivated? Can high efficiency filtering be effective?
Yes to all of those things, potentially. I will kind of go back to what are we trying to accomplish? So, is this the type of building that needs to run throughout a pandemic like a hospital? Or are we talking about a school or an office building where we are trying to make them healthier to protect against influenza A or influenza B? We are seeing yes to all of those things. So UV lights potentially have benefit there, but we struggle with some of the data too. So we see research that points towards UV being a good technology to apply, but we also have to be careful too. So one thing I know is that as engineers, we have a nasty habit throughout our history of throwing engineering stuff at things and creating unintended consequences. So one of those things that can exist is UV lights, if they're put in the airstream, or some of the other technologies that we've seen, they kind of wipe out everything in that airstream. So yeah, they get the viruses, but there's good stuff in that air too, as we understand more about our microbiomes and how we are this connected species. We don't know if it's good to wipe everything out. So in the health field, they have the precautionary principle, which basically says, if you can't prove that something's good, you should be really cautious about it. And I think that's what we are a bit concerned about. So, we're looking at those technologies. We're looking at them from, maybe kind of point application or specific applications. We actually have a couple studies on our webpage, I believe, and Marcel Harmon, our resident anthropologist who leads our R&D team, you give him a follow on LinkedIn, he's published quite a few things on UV lights and germicidal, anti-germicidal ambient lighting as well. And so it's kind of a mixed bag is what we're seeing. I know that's not the answer people want. They want the easy button. Unfortunately, it's not necessarily there.
And it does look like, Chuck, thanks for sending a message to all attendees that United Health Group and Optum, they're using UV lights and HEPA filters, but to be careful with finishes because the UV fades certain products and materials.
Yep.
Great. Well, we're about wrapped up here. It's almost 15 after. So I just want to thank everyone for attending and participating in today's Earth Day webinar.
All right. Thank you, everybody. Enjoy your Earth Day.